We are now solving problem 21 from the AMC 10B from 2020. In square ABCD, points E and H lie on AB and DA respectively, so that AE equals AH. Points F and G lie on BC and CD respectively, and points I and J lie on EH, so that FI is perpendicular to EH and GJ is perpendicular to EH. See the figure below. Triangle AEH, quadrilateral BFIE, quadrilateral DHJG, and pentagon FCGJI each has area 1. What is FI squared? Well, let's just utilize this first sentence. In square ABC, that means this is a square. That means this segment squared is equal to this area. And triangle AEH, quadrilateral BFIE, quadrilateral DHJG, and pentagon FCGJI has area 1. This has area 1, BFI. This has area 1, DHJC. This has area 1, and this has area 1. So basically, they're saying that each of these individual shapes have area 1, and when you sum up all these areas, you get 4 times 1 or 4. That is the grand total area of this square. Since it's a square, that means the side length is 2. So that means this is 2. 2 times 2 is indeed 4. So we have that. Now, we do know that these two lengths are equal, and since it's a square, there's a right angle at here. Since these two side lengths are equal, this is going to be a 45, 45, 90 triangle. 45. And since all these area, okay, and since this triangle's area, AEH's triangle's area is 1, therefore, each side of this triangle, isosceles triangle, is going to be square root 2. So, EB is going to be 2 minus square root 2. Okay. Well, we want to find FI squared. Now, let's see if we can construct some triangles with special properties. Now, we don't really want GJ. We're not sure if that's equal to FI. So what we do here is we can extend all these lines FB and IE. You can extend them all the way until they meet. Until they're at a meeting point here. Okay. Now, what do we know? This is still a straight line, and since this is 90 degrees, this angle has to be a right angle. Since this is 45 degrees, this also has to be 45 degrees because that's the criteria. And 45, and if these two angles are already known, we can determine what this angle is. Since this one's 45 and that one's 90, this one has to be 45, meaning this is an isosceles triangle. Therefore, this length is also 2 minus the square root of 2. Okay. So now we can find the area of this small equilateral triangle here. This is 1/2 times 2 minus root 2 squared. This is going to be 1/2 of 4. 4 minus 4 root 2 plus 2. This is going to be 1/2 of 6 minus 4 root 2. And this is just going to be 3 minus 2 root 2. Okay. So we have this area, and we can sum it to FI to get the area of that. And, and we also can know this stuff about this triangle, FI in this point here. This is a 90-degree angle. This is 45 degrees. That means this also has to be 45 degrees. So, that means this is an right isosceles triangle. We can sum 1 plus 3 minus 2 root 2 to get this total area. This is going to be 4 minus 2 root 2. Okay, now we can write. Now you might be thinking, why do we need this? Let me just write this in a more easier way to understand this problem. Since it's the area of this big triangle, this is going to be 1/2 of FI squared. Since this is a right isosceles triangle, this is going to be 4 minus 2 root 2. We want to find FI squared, so we multiply both sides by 2. FI squared is going... That's not good, but you get it now. FI squared is equal to 8 minus 4 root 2. And this is going to be our answer for FI squared.